And Google is pretty much killing the race right now, like in a big way. My name's Johannes Start, and I work for atVectorform, an invention company from Detroit, as a solution engineer for mobile and emerging technologies. Today, I want to talk to you about how to communicate with machines. So, vastly different to what we heard before from Eugenio, communicating with machines has a lot of different requirements than communicating with computers, right? Humans. So let's take a second first to talk about how humans communicate with each other and what makes human communication quite special. So basically, there are two different types of communication. I'd say very simple and basic physical communication, and more advanced and complex communication. Physical communication includes what we do with our bodies in a shared physical space, right? So that includes gestures, facial expressions, emotions, and sound. If we look at how animals communicate, it's pretty similar, and you can compare the two with each other quite well. Now, comparing that to the more complex types, like language, either written or spoken, that's vastly different, because with language, we can transfer abstract concepts and ideas. We can give very complex commands, and we can exchange a lot of different information, which we just can't with basic and simple communication. So putting that into context of user interfaces is quite interesting, because on the one hand, we have humans that have a large range of different ways to express thought and complex information and to communicate all that. And on the other hand, we have computers that are very data-driven, that are very simple and are very logical, not emotional, right? So the question of user interfaces emerges. How can we bridge the one world into the other world, and how can we have a machine understand a human, right? So what we started with back in the day, and this isn't the first one of the type, but one of the first, is the Commodore 64, and that's one of the first interactive computer systems. Interactive because you can type things, press a button, and the computer will respond. You don't have to reset the whole machine to do something. You can basically just enter commands and you get stuff back. So going back in time, this was I think the oldest computer that I ever touched. And it was quite interesting for me as a kid to actually use this, because it's so vastly different to the way I got to know modern computers and to the way how humans communicate, right? This accepts language. You can type things into it. It uses characters and symbols. And as a matter of fact, it uses the same characters and symbols and language that we use as humans. It's English, and it uses basically the alphabet, right? So it has a keyboard. It's semi-easy to learn the concept of a keyboard. It has keys on it with letters, and the letters are the ones that we know. So I start typing on it, right? The symbols appear on the screen, all good. The computer's responding. So I think it gets me, right? I hit enter, and it does not. It didn't understand anything I told it, because the system is built in a way that I can enter anything I want. So it's pretty much an infinite canvas of information that I can throw into this machine, but the machine expects a very, very small subset. And the machine doesn't tell me that it expects a very, very small subset. I have to know that. And not only do I have to know that it accepts a small subset, but what exactly I have to enter, what command I want it to do, with what parameters, and I even have to know the right order. If I have a typo, it'll not accept it. So if we look at how natural the user interface is, it's not very natural at all. If we look at how it matches user expectation, it does not match user expectation at all, because I think I can put anything into it. I have a keyboard, right? I can put my language in it, and it doesn't understand me unless I read a book about how to use this thing. If I stick a floppy to the drive and want to execute a program off of it, I first have to connect to the floppy drive, load the program into memory, jump to the start position and run it. So that's not great. But the freedom of input, which is infinite, is quite important, because we're going to come back to that later. A little bit forward in time, not much, actually just 2 years later than the Commodore 64 was released, I think in 1984, was this user interface, one of the first graphical ones, not the first one, that has a vastly different concept of interacting. So what they did was they thought hey, how can we take a physical concept that people get quite easily and transfer that onto a screen? Now, typing text is something we get as a concept, but it's not great for a user interface, at least back then. This is a bit different because we all can imagine what a desktop is and what things on the desktop are. If I have a note laying on my desktop, if I take it and read it, and I take it away and put it in a drawer, I know like physically where I'm putting things. So it's basically taking a concept that we know from real life and putting it in a two-dimensional screen. If we look at how natural it is, therefore it's like kind of decent, right? It's a concept that we can understand, that we can relate to, and we don't have to really know how the machine behind it works, except for maybe knowing what a file system is and where to like put files and stuff. Does it match the user's expectation? Kinda. I mean, it shows you pretty much like what you can do with it, and if I click system folder, it'll probably open up the system folder, but do I have to click once or twice, or is it a right click? Is it a middle click? I mean, we all know this scenario from our parents when they're like, hey, I double-clicked this thing and it was a link and all these windows open up and nothing works like it should. So this is way better than before, but it's not optimal yet at all because it shows you like certain paths so you can take and it shows you clickable areas, but it doesn't tell you how exactly you can do it, and it's not natural the way how we interact with it at that level, right? If we look at the freedom of input, it's starting to get limited, and that's what makes it usable. So first we had like this infinite space that we could just type anything into, and now we're starting to get limited because we're showing clickable areas, we have menus, and we have options for the user to choose from. Jumping forward in time a long way, because in between like there wasn't too much of a big change in the base core concept. 2007, the iPhone was introduced. So the new thing about the iPhone was not a touchscreen. There were devices before that with the touchscreen, even like capacitive ones, right? The great thing about the iPhone was that Apple really sat down and thought about the concept of interaction with a finger or with like natural body parts, right? And Steve Jobs said this back then when he introduced the iPhone, that you can, why would you have to carry a pen around with you to type on a small screen if you have a finger with you all the time, right? And it's natural for us to touch things that we want to do things with. And it's natural for us to grab things and to make things bigger and all these things, right? So if we look at how natural this user interface is, we can say it's pretty natural. We see things, we can touch them, it's pretty clear, there are visual cues what you can touch and what you can't, and things happen that feel natural to us. Matter of fact, it's so natural that kids learn how to use these devices before they even learn how to read and write. So if you like have a 1 or 2 year old, it's really interesting. Give them an iPad and see how they use it. It's crazy. They can't read, they can't write, but they can navigate that thing like a pro, probably better than my parents even. So that's super, super interesting. Now, does it match user expectation when using it? Yeah, it kind of does because we know what we can click and what we can't. What's the freedom of the user input? Like, can we put anything we want into that device? No, we can just touch the things that it's showing to us. If we have a travel app open and there are 3 buttons I can press, then I can press the 3 buttons and a home button, and that's it. And that's what makes it very intuitive, because we can choose very, very, very clearly from a very limited set of options in a very natural way. And that's what made this device explode. Now, going a step further, Apple said, hey, why touch the phone if you can just talk to it? Isn't that like a great way of adding a new user interface to the device? And in theory, it is, because it's very natural to talk. We do it all the time. That's our like main means of communication next to writing and reading. It allows us to exchange very complex concepts and ideas and information in a very short amount of time. And it also allows us to give or tell the machine what we want in a very short amount of time as well. If we look at the freedom of user input, now what we saw before is we had like infinite, and then we had like semi-limited to very limited to super limited. And now again, saying things using our language is like infinite again. It opens up the space to just like say anything you want. And that makes it difficult because matching user expectation again, while being able to say whatever you want, is very hard. And that's something that Apple noticed really quickly after launching this product, was that the basic features like setting up a calendar invite, like texting a message or calling somebody, they work great, and that was totally fine. But how can you tell the user what he can do and what he can't if you allow him to basically speak with their voice, right? Now, a human you expect to understand pretty much everything he's saying unless it's like utterly complex or you're too drunk to speak or something, right? But a machine doesn't work that way. People have to implement the functions and the features that are behind this interface. And if you don't tell people like how and what's possible, it's hard for them to know that. So I guess that's like pretty natural. So how does the user know what she can do with this? Going a bit like forward in time again, the Amazon Echo was released about 2 years ago. And this is quite interesting because they just took the graphical user interface away completely. They said, okay, here's a device, you put it in your home, you can talk to it. There's a cloud platform, it's called Alexa behind it. It'll do all the gritty work and make sure that users understood and will basically enable it to be a good voice user interface. Now what's really interesting about the Alexa platform and the Amazon Echo is that they limited what you can say per, I'd say, application to a very limited context. So what Amazon did was they set up different hierarchies of I'd say personalities or what they say skills you can talk to, right? So the highest personality or the highest level is Alexa herself. So if you start talking to the device, it's usually Alexa you're talking to. And Alexa can do very simple things like tell me who the president of the United States is. What is 2 + 2? What's the weather going to be tomorrow? Like very, very simple things. Things that we expect a digital assistant to just do, right? But things that go past that, users don't expect Alexa to do. They expect the skills to do it. And the way how they built the voice user interface is quite interesting because you don't ask Alexa directly anymore. You tell Alexa to ask somebody else. So take the Deutsche Bahn, for example, and looking at transit. You would ask basically, Alexa, ask Deutsche Bahn when the train from the Hauptbahnhof is leaving to Frankfurt. So now what they did is quite interesting because the first level of Alexa, right, now knows that she's not responsible for what the user is asking. It's Deutsche Bahn. And Deutsche Bahn, from the context that it's providing, is very limited in itself because what did I do? Transportation. I'm probably not going to ask Deutsche Bahn when the ice cream shop next door is going to close, right? So that's kind of smart what they did there. It does have a problem, though. So if we look at what Siri is on the phone and what Google does with the Google Assistant, for example, when you ask it something, you get a audio feedback, but you don't get a visual, and you get a visual feedback. Whereas with Alexa, you don't get a visual feedback with this device, which means you can only ask for very simple information. If you ask for, I don't know, the history of train departures at the Hauptbahnhof over the last 2 weeks for a specific train, and she starts reading those to you, you're going to be like, after 2, I'm not listening anymore, right? But if you see it in a graphical user interface, it's a graph, it looks nice, it's the correct way of displaying information. And that was something that Alexa has pros and cons, and specifically the Echo device in regards to that. But to tackle that, they introduced a new one, the Echo Show. It's basically a tablet with a stand and a better speaker in it. I wouldn't say that this solves all the problems, and having the Echo Show as a stationary unit introduces a whole bunch of other questions that you could bring up. But it's an interesting take that Amazon is bringing to the market because essentially what they did with voice technology was similar to what Apple did with touch technology back in the day, right? There are other voice assistants out there when Amazon launched their Echo. But what Amazon did was build a voice-only and voice-first device. They took the whole concept of user interaction and just focused on voice first, and now they're adding other features. Just like Apple focused on touchscreens and touch interactions first, and then added other features. So it's going to be interesting to see where this goes. I'm not sure if this device is going to really hit the market, especially outside of the US, but we're going to see. So a question that comes up a lot is, are voice user interfaces a complete game changer? Are they going to completely revolutionize how we interact with technology? And are they going to be like the next big thing and replace all the computers and stuff that we have? I think the answer is very simple. No. Voice user interfaces are great for what they are, but they're basically a step towards natural user interfaces. And right now, they're a good try towards natural user interfaces. So natural user interfaces are all kinds of user interfaces that interact with humans on a very natural way. So we talked about the different forms of how humans communicate before. That may include our facial expressions, it may include our gestures, it may include sound and voice and language. It may include our context and how we physically move in it. And that's basically this whole like space of natural user interfaces where computers have to start learning how we communicate, and we have to stop learning how computers communicate. Because I'd say like the more complex our computer systems get and the more connected they get, it's going to get even harder and harder for us to understand how they work and what they do and what's behind them and orchestrate 300 smart home devices in our home because even our water cook is going to be connected at some point, right? So the systems have to like start communicating with each other and learn what the user is doing. And that's a very, very great thing about natural user interfaces, and voice is one of the first like steps that's mainstreamly being taken right now with Amazon Echo and Google Assistant. So getting back to voice, I'd like to talk shortly about the intelligence behind voice assistants and where we're at right now and what's missing to really make them great and really make them intelligent. The first part is speech recognition. And speech recognition has pretty much been completely, or not completely, but it's pretty much been solved. So if we look at the rate of the quality improvements of speech recognition over the past 18 years, we see a 30% improvement like solely over the last 3 years. So basically we had like a long period of a lot of research where not too much happened, and then we had 3 years where it just like totally went through the roof. And in those last 3 years, 2 years ago, the Amazon Echo got launched, we got to a point where the like voice and natural language of humans can be translated with a very high accuracy from speech to text. And this is necessary to be able to process it further and make a computer understand what we're trying to say. The second point is being able to analyze the syntax, right? So that means look at how we construct sentences, where the specific parts of sentences are. And it's arguable a point if it's completely solved or not. I wouldn't say it's 100% solved, but we're at a point now, and that has only happened recently, where we can syntactically analyze and basically understand pretty complex sentences already. So there are APIs like the Cloud Natural Language API from Google that does a really great job. They just released a new version. They talked about it at Google I/O, I believe, just like recently. And what's really great about that is that like pretty much any like English input we throw into it, we're able to analyze the complete like syntax of that sentence. But what it does not give us is the semantics. So we know where things are, but we don't know what it means. We have systems that allow us to approximate what it could mean. And in specific cases, we can't even know what it probably means. But the problem with language is that it's so complex. And you can build like, I don't know, like take the English language or German language even better. You can build sentences that are so long you probably couldn't even like print them on that screen, right? Now make a computer that's able to understand that. That's really hard. So semantics specifically for voice interfaces are especially hard because the way we speak is vastly different to the very structured way we write. So often when we speak, we don't have the correct syntax, we don't use the correct words, and usually we leave away all the important information. Humans are smart and they can infer a lot out of the context. So if we're sitting in this room and I say, it's a bit dark here, what I'm trying to say is somebody turn up the lights in this room, in this tower right now, but a computer doesn't know that if I say it's a bit dark in here, right? Now if I tell that to a human, it's pretty clear to us. So what human or computer systems would have to do to be able to really understand the meaning of sentences is they would have to be able to infer a lot of context and be able to like think somewhat on their own. And then the last part, and that's like the like crown discipline here, is the conversation. So if we have all of that before, and that's going to be tricky enough to get the semantics correct, like really correct, conversation is like the next big thing. The computer understands what I'm trying to say, and it understands my intent and the broad range of conversational aspects maybe. But being able to have a coherent conversation with a human is really hard. There have been algorithms that seemingly in specific scenarios are able to fake a human conversation to a pretty high amount or a pretty high degree. But to like take a specific theme that humans are very versed in and put them in front of a machine, they're probably going to find out that it's a computer within like 1 or 2 sentences max, if it's programmed really good, otherwise before. So we talked about that already. Then let's take a short look about where we see assistants and especially voice assistants. Desktop and mobile, I guess naturally, since Siri came out, Apple has pushed it throughout their whole ecosystem. They're on Macs now, they're on the tablets, they're on mobile, obviously. Google is rolling out their Google Assistant throughout all of their devices, throughout Android, throughout even iOS now. So that means Google Assistant is right now the most cross-platform assistant around. Amazon is catching up really quickly too, but more about that later. The smart speaker market is really interesting as well, and I'm going to get into a bit more details around that later. We have two key players right now. One is Amazon and one is Google. So we have the Amazon Echo and a bunch of like smaller devices around it, like the Echo Dot and Echo Tap and a few other devices. And then we have the Google Home. What's interesting about Google here is that Google doesn't only offer this device and a very, I'd say, minimal integration in other ecosystems, but Google offers full integration into their Android platform and now even iOS. So that's interesting. Automotive is super important for voice assistants and digital assistants because when driving, I don't want to touch buttons and I don't want to look at a screen somewhere. I just want to tell my car what I want it to do and it'll do it. And in the future, when mobility is going to become more of a service and cars are driving on their own, what am I going to do in the car when all my friends are busy doing something else? I mean, yeah, I could probably work, but if I could have a conversation with my car or talk about, I don't know, work topics and discuss like a few items that I have to get done for the next meeting with my car, then that would be quite interesting as well. And last but not least, very important, smart home. If we look at voice assistants, and we're going to see that in a second, the main use for them is the smart home and controlling smart devices. It's way more convenient to say, Alexa, turn on the lights in the living room than to get up and press the switch. Pretty much all of the other use cases that Alexa and Google Home offer do provide value, but not at the level of what they can provide for smart home. So looking at the platforms, we have four main platforms. As I said, Amazon Alexa, Apple Siri, Microsoft's Cortana. They're starting to build that out really big now, but it's not all published yet. And the Google Assistant. So just to point out a few highlights, because it's a bit of a lot of information here to run through all of it. Advantage-wise, I think like these two here are super important. E-commerce and basically the advantage part here. So Amazon Alexa right now in the US has around 70% market share. So that's quite interesting if you look at how many devices are out there, and that they're pretty much all like, or most of them are on Amazon's side. It's probably going to change with Google pushing their offering, but Amazon, yeah, is pretty much owning the market right now because they were first. E-commerce is super important because Amazon obviously has some goals around the Echo, and one of them is definitely selling products through it. So the Echo is, or the whole Alexa platform, matter of fact, is e-commerce enabled by default. So today you can buy an Echo and tell your Echo that you'd like to buy tomatoes and it'll get you tomatoes. Apple Siri was one of the first platforms out, especially the first mainstream platform out, really interesting. We're expecting them to release a voice assistant, digital home voice assistant at WWDC, or at least announce one. So let's see how that goes. What's important about Apple is that they have a lot of devices out in the market. So there is a huge market penetration by Siri, but it's not very open to third parties. So there are a few like minor things that you could do through it as a third-party developer, like payments and messages and stuff like that. But you can, for example, build your own smart home integration or add your own e-commerce platform and then buy through voice or something. Microsoft Cortana is not like out in the market as like, or in the state that Amazon Alexa and Google Assistant are, offering a third-party SDK to build like your own full applications. We're expecting that to come out soon. It's in closed beta, but we'll see. What's important about Microsoft is, and that's definitely their advantage, is that they build Office, Outlook, and they have a deep access into the gaming industry with Xbox, right? So Microsoft's Cortana take, I think, will be a bit different than the other platforms and way more focused on productivity. How can you use voice when you're in an Excel sheet or in a PowerPoint document? Your presenter notes, for example, or are you just going to be speaking them? That's starting to be done right now, but like, what's the next level of it? That's going to be super interesting. And Google is pretty much killing the race right now, like in a big way. So they just brought out their Google Assistant end of last year. And within like, I'd say about half a year, they have full integration into their Android system, rolled out over all the modern Android devices. They just brought out an iOS application that offers full Google Assistant support. They have the Google Home device, which is estimated to capture around 20 to 25% market share this year. And they're offering a payment platform, and they have an open platform, which has always been key to most Google products, right? If you look at Android, it was so successful because it's an open platform. And they're doing the same thing for Google Assistant. So it's very interesting to see where this is going to go. Market share, we talked about this shortly already. Amazon Echo, 70%. Google Home, 24% by end of this year. And everyone else is going to be at like 6%. This is, one second. This is for the digital home assistants. So this does not include Siri and I'd say mobile-only digital assistants.
And the question would be, well, first of all, the Cortana, I believe they actually released the Cortana as a connector on Microsoft Bot platform. So you can sort of create bots for Cortana already. Did it like a week ago, something like that, as far as I remember. And the next question, do you have something on Viv?
No, we don't have anything on Viv. Viv is interesting, but not rolled out to the market. And
with Galaxy S8?
Is that the full Viv platform, or is that parts of the Viv platform? And with Build last week, that's kind of interesting. I believe they announced it. I'm not 100% sure on that, the Microsoft Bot Framework integration, but I'm not sure if it's actually released yet. We haven't been working yet with that, so I can't really say too much about that. But definitely interesting to look into. I'm going to do that after the presentation.
And having a separate device standing there. I heard it's about the energy consumption. Why do you have Alexa separately or Google Home? I mean, I understand if you think it one step further like Jibo, a little social robot that interacts and shows you also his reaction and looks at you, then it's kind of okay, but Alexa could also use my phone, or what's the reason?
So the reason, or the main reason for Alexa is that it's, or the Amazon Echo, matter of fact, that it's a sole alone standing device is that you don't have to grab your phone. You can just like blurt at it or like start talking to it at any given time. You can be laying on your couch, phone in another room. You can just be like, Alexa, turn on the lights or something, right? So the key element here is that you don't have to do anything but activate your voice. Whereas with a mobile, you have to get it out of your pocket usually, or right now, because the microphones aren't good enough and the speaker isn't good enough to respond to you.
But then the next step would be a social robot that can follow you, interact with you. Not just like Jibo standing on the table, but some small robot that follows up to you and interacts with you, right?
It depends on from which angle you see it. I feel like a lot of people would be anxious about having moving robots in their house that follow them around. I think it's more interesting to...
People would have been anxious to have Alexa listen to everything they say and store it in the cloud, right?
That's definitely true. I think that the important part here is to think about more of like how can technology become invisible and more natural to us. Thinking that somebody is following you around like a robot and listening to you is thought in a very human way, right? Because we are used to when we speak to people that they have to be close to us and they have to follow us around, that they physically have to be there, because otherwise it doesn't work, or we have to call and use some device, right? Now if we think this a step further, we see technology really becoming transparent and invisible at some point. We want to have a context and a system context that knows where the user is, that's able to understand the user wherever he is, and is able to interact with him in whatever situation he is in his home without having to be followed, right? So let me give you an example. We built this scenario for natural user interfaces for one of our clients that we presented at CES this year, where you can walk up to a kitchen counter and you can interact with it in your natural way, and it'll automatically detect what you want it to do. So take a sink, for example. You walk up to the sink, you have a cup of water in your hand. You put the cup in the sink and it fills it with water at like drinking temperature, which is going to be a bit colder. On the other hand, if you go up to the sink and put your hands in it, the action you want is vastly different. You want it to run water, warm water probably, until your hands are clean and you take them out again. If you want to wash an apple, it's different again. So basically, we don't think, or we don't see the future in like a robot following you, but having a smart context around the user that's able to understand what he's doing in each situation and in each context that he might be in, which can be camera-based, which could be something following the user, but would not preferably, which could be Alexa microphone-based, which could be radar-based, and there are a bunch of other solutions that can be integrated into a system like that. Okay, Yeah. Google Glass or, yeah, okay, Google Glass is an interesting topic. The whole technology world freaked out when they saw Google Glass. It was like, oh my God, this is so amazing. Until they went out on the street with them. And somebody was like, what's that? That looks creepy. And people realized technology doesn't or shouldn't look like technology. It has to look like things that we're accompanied to and that are natural to us. And having like this thing in our face that's not a glass and it's not, I don't know, something that's completely different and it looks kind of creepy and it has a camera looking at everything you look at, made people not really trust the device. Additionally to that, we believe Google didn't do a great job with like how the whole user experience around it was contemplated. For like a first version, a first prototype, it was great, but they sold the vision of it and made people go out with that vision, and it by far was not there. Now, if we look at what Microsoft's doing with their HoloLens, they're doing it like from a completely different angle. They don't expect people to take a HoloLens, put it on, and walk out on the street and go to a cinema with it, right? They expect people to use it in their workplace, in their homes, and so on. And they also brought the technology a few steps further to a point where you actually have three-dimensional holograms that you can interact with your gestures and your voice, and they stick to the room, and it's not just like a screen that's always visible to you. So I think Google Glass was great for what it was, but it was a product at the wrong time with the wrong user experience for the story they were telling. Yeah?
Do you think at one point that maybe Apple needs to allow third parties to access their voice assistant, Siri?
Definitely.
Yeah.
Yeah. Yes.
Seriously?
As soon as possible. I mean, yeah.
That's the wave approach, right? Open series, basically.
I mean, there are two options. Either Apple hires 20,000 developers and has all of them build Siri skills and run them through their internal testing and all that, or they open it up and do what they did with the App Store, right? That's what made Apple and the iPhone so successful with what it is. So even though the platform isn't completely open, it still enabled them to utilize a bunch of development resources that they did not own, that they did not pay for, while still promoting themselves and while still taking 30% of any revenue that goes over the platform. So yes, it should definitely be open. Okay, so then why build a voice user interface after all that we heard before? There are three simple reasons. First, drive innovation. You want to be like, in your market, you want to show that you're an innovator. You want to bring to market a like first case in using this new technology. You want to increase empathy, which is interesting because basically what you're doing is you're giving your brand or your product a voice that you can talk to. You're making it very, how should I say, or semi-human. You're giving it a persona. And you're giving that away at a very convenient way to access it, right? You can basically just like start talking to it. You don't have to call anybody or wait or open an app, get your phone. And you can reach more customers. They're estimated to be over 10 million digital home assistants in the US market right now, so that's quite a number already. Looking at what people are doing with digital home assistants, it's quite interesting. So 2 out of 3 people that were asked are using it to listen to music. So as you can see, it's basically transforming the way media streaming is working and how we consume it. Another important part is news, weather, and traffic. So anybody providing content should be thinking about like how can our content be provided via voice. And what's very important to us is lights, thermostat, and fans, so everything in the smart home sector. We see it's not on the top of the list, but 75% of consumers that use this technology say that they are super interested in smart home and it is very appealing to them. Might be a bit too expensive right now. So how do you build for this? We have a very simple process that we run through. It's 3 steps if we look at Alexa, for example, design, develop, and certify. What's important and to us is that we understand how users interact and how they naturally interact. So we do a lot with interviews. We sit together with users. We do dialogues and play them through. We have them act out Alexa, have them act out the user, and write down everything we hear. Then we take that and formalize it into basically conversation flows. We build diagrams that show like how the conversation can flow, what's connected to what, and then we develop a persona for the voice, right? And that's very important if you speak about like how people communicate, especially via language. There's a lot of emotion, and there is a lot of like persona in the way we communicate. Every human has it naturally, machines don't have it, so we have to give it to them. And it has to be designed to fit the brand or the product that it's being represented through. In development, what's quite interesting is that if you use the Amazon Alexa platform, for example, they take a lot of the natural language processing away from you. They give you a very structured format of data that you can process. But there are a lot of quirks and a lot of things you have to be aware of. And one of the challenges is that you have to generate a long list of things a user could say. And you could just like have per like feature that you want to present or per intention that a user wants to say, have like 2 or 3 or 4 sentences. But theoretically, there are probably, I don't know, for a lot of things, even an infinite amount of things that you could say to like imply that intention. So the more sentences you have around it, the better. And we basically have a tool that generates a bunch of sentences if we give it a certain grammar, and we built that on top of the conversations that we did with users before. Running through that real quick, at the end, we have to hand it into certification. So this is pretty much similar to what the App Store does, not to what the Play Store does. And there is a quite extensive like list of requirements that has to be fulfilled for Amazon and for Google as well. If they're all like fulfilled, then you're launched and you're in the store and everybody's happy. If not, then you have to talk to them, maybe do a few little changes, and then hand it in. After we went through all that, we start from the beginning and think about other cases and other ways and look at user problems and how to basically iterate on the product that we have built. One question that always emerges is, what about privacy? And I heard that peek up before. Privacy in this whole space is super interesting, but that's like a whole separate conversation and a whole separate presentation in itself. So let's discuss that over beers, or do a separate presentation on that, because otherwise we're going to be here till midnight. Do you have any questions?
Yeah, is it true that Alexa records everything and stores everything in the US?
Yes and no. So Alexa does not record everything per se. Alexa only starts recording if it understands the Alexa wake word. What it then does is it takes the language that is spoken and streams it to the cloud until it believes that the spoken sentence is over or a specific time threshold is reached. So that means it does not record everything around it. It just records when you say the wake word. The data, depending on which location you're in, is streamed to a European data center or American data center. What Amazon does with the data afterwards is up to Amazon, and they probably copy it to the United States.
So the question would be that basically you work for sort of an agency, digital agency, as I understand. So you build this voice assistants for clients.
I work for an invention company. We also build voice assistants for clients. We work with a lot of emerging technologies. Voice is one of them, to help our clients, mainly world-leading brands, to solve complex problems and reinvent themselves in the age of digital disruption.
What kind of data do you have from the, because I mean, I can imagine that you have like the kind of question that they ask you, but do you have also like the entire voice recording of the user?
No. So we don't get what the user said. Depending on the platform, we get what the user said in text representation. With Amazon Alexa, for example, we just get what was processed by Amazon and states the user's intention and potential parameters. Whereas with Google, for example, we do get the full sentence that the user said.
Okay, great presentation, first of all. Do you think that to some extent the rise of this voice assistant will change the way that we communicate in order to be, you know, more precise? Referring to your example of it's a bit dark in here. I mean, you could have said, can someone turn on the lights, right? And that's probably something that Siri and everybody else would understand. So do you think that somehow it will also change how we communicate, at least to some extent?
I think it might make us aware of how we communicate more often, but as humans, especially when we talk to each other, we don't put too much thought into how we build our sentences and structures. It's way more subconscious than we sometimes think, the way we communicate and the words we use and the way we formulate and the amount of preciseness we put into our sentences. It's interesting, if you see people, especially kids, talking to Alexa, the first thing they try and do with the device is like just talk completely natural. They're going to say thank you and please if they were raised to be friendly, right? Although nobody would have to say thank you and please to a device like Alexa, right? But they do it anyway. And what comes to their mind after like a not very long time of interacting with it is that it works differently than humans, and they start changing the way they talk to it. They start rephrasing, and they sometimes even have to like think for a second how they have to say things so the device is going to understand it. For for grown-ups, it's easier to adapt that language, but I think that right now we're strongly differentiating if we're talking to a machine or if we're talking to a human. And as long as the machine interfaces or voice interfaces are not going to get way more natural, I don't think that it's really going to change anything with the way we talk to computers, because, how should I say, the type of interaction or the way we, how should we say, the way we sort it in our brains is just a completely different one.
I believe this will actually change the way we communicate, maybe not us, like not our generation, and not even the kids which are born like now or 5 years ago, but the kids which will be born in 10 years or something, when the interfaces will be quite adopted, but maybe still not human level, and when they will be more more widely spread, basically, if they will be existent in every or nearly every family. This will mean that the kids will hear their parents talk to the device this way more often from the very early childhood, and what kids do, they just repeat stuff, and that's it. So I believe it will have some impact. I don't know which kind, but I believe so.
All right, then to finish off, I'd like to just show you a real short video about VectorForm, the company I work for, and some things that we've done. It's just a minute long. We're hiring, so if you're interested in building the future with voice or anything else with new technologies, holograms, virtual reality, or if you're just interested in building mobile applications, we're a great company to work for. And here are some pictures of our office.
Yeah, this is Houston, we're copying. F2, 1/160th second. Neil, we can see you coming down the ladder now. Roger, we copy. Pretty good little jump. And step off the lamp now. That's one small step for man, one giant leap for mankind.
Yeah, so if you're interested, check out vectorform.com. Feel free to drop us a message in the contact form or just reach out to us after the event. Thank you very much.